The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to our webinar. This webinar is the third in a series on prospect mapping from interpretation to volumes. The first one was in September and broadcasted by Mazzolina on time structure maps, and the second one in October was given by Carolina on depth maps and working with some depth conversion to generate maps in Petrosys here. Today we're going to talk about thickness maps. My name is Peter Richards, Senior Support Geoscientist in our Calgary office. This webinar is being recorded and will be placed on our website in the next day or so. All attendees are muted on purpose to ensure the best quality audio by reducing the background noise. If you have any questions, please type them in the question box so we can record and answer them at the end of the webinar. In our presentation today, we're just going to have a quick look at why we'd use Petrosys for thickness maps and some of the data integration that's available, and look at some of the Petrosys computational methods, and we'll go through some examples in the demo. And then we'll talk about workflow management too as well. So why would you use Petrosys to generate your thickness maps? Well, it integrates data from a variety of data sources, so interpretation toolkits out there, and from such applications like Halliburton's decision space, Schlumberger's Petrel, and so forth, paradigm interpretation tools. So it's able to grab information directly from those data stores and pull them into the mapping process for an easy way to work. It also has the flexibility to create and edit services for many types of data. You can be pulling in well data, seismic attributes, or even shape information, data coming from Excel spreadsheets exported from other non-connected tools, or even pulling in text data. We have a computational tool that's fairly intuitive and comprehensive in how it can generate formulas for computations and so forth. We'll have a quick look at that too as well within the demo. It has a very logical interface, and you can create and save your own custom formulas. You can create them from scratch, or there's actually a bunch of example formulas in here for you to choose from and make modifications and then save them based on your workflows. The variables that are used within the computation process can be either grid, constant, or interpolated values from a list of data. As well, there's some powerful operators and functions available to people working with the computation arithmetic operations. We'll show a quick illustration of that. And within this environment here, you can apply conditional or test statements to test for certain features, or to make sure that things are passing your conditions properly. As well as you can incorporate multiple statements within the computation too as well, which makes it much easier then to make multi-step processes within the computations. Petrosys also has an easy to manage and repeatable and scriptable as well workflow generation tool. Allows you to generate workflows to share them with colleagues, as well as repeat those on a regular basis, or even script them to make them automated. As an example of the data integration, you can see we can pull well data from interpretive data sources like Halliburton's landmark tools or IHS, and seismic from various interpretation tools like Doug or Petrel, and pulling formation attributes from such tools as Geolog and Paradigm product. It could be other types of attribute information, maybe from petrophysical attributes coming out of a corporate standard tool that's being used. So we can pull that information in through shape files or text files or even Excel spreadsheets and so forth into the whole mapping process to generate your net pays or thickness maps, as well as other types of maps too as well. So let's just get right into the demo here. So in the first couple of webinars. The first webinar we were looking at creating time maps, and in this process and everything like that, we illustrated the generation of the turbot time structure formation. And this is the one that was generated during that webinar. And this will be one of the base formation surfaces that we're going to use within our thickness calculations. As well, in the second webinar, we talked about taking this time horizon or time surface here and depth converting it to generate a map of a TVDSS version of the surface that we just saw in time. So this is the top turbot, true vertical depth subsea surface, and adding all the elements in here too as well. We're going to go through and then generate an isopack map through from this using some of these map surfaces that have been created already. We'll pull up Surface Modeling Tool, and I'm going to open up the task that was generated within the first couple of webinars. And the first webinar, when they created the time structure surface, Messalina did, she generated the top turbot surface here, and the task file to do that is illustrated right here. We're pulling in the top turbot interpretation from the Petrel project, and it's going through and creating a grid from it, incorporating the faults based on fault sticks that are being pulled also from the Petrel project. And the automated process here will pull in the fault sticks and the interpretation, and will generate a set of fault polygons for that particular surface. And the output then has a surface model or grid with the associated fault polygons for that surface. What I did was I copied this particular task and pasted it here too as well to do the next formation top, the top nests, and ran the same sort of process, taking in the interpretation from Petrel for the top nest horizon, and using the fault sticks to generate a time structure map for the nests. In the webinar in October, Carolina took the top turbot two-way time and did a depth conversion on it. And she took grabbed the two-way time grid and utilized the well information, the well tops from Petrel as well, to generate a formula to apply in the arithmetic operations to do the depth conversion. And you'll see the formula right here. By turning this feature on here, this then becomes copied over into an arithmetic operation as the second part of the depth conversion process. And you'll see that in this grid arithmetic task here that was part of what Carolina did during the depth conversion. What I did too, because I needed a second depth surface for the interval, I copy and pasted this process that Carolina had done and generated the same sort of TVDSS surface for the top nests. So now we have our two true vertical depth surfaces that we're going to do the thickness maps with. So I'm going to go into Grid, Processes, Arithmetic again, and I'm going to clear this thing, and I'm going to use one of these formula templates here that is provided for you by Petrosys. There's a number of different types of formula templates here, and there's some classification in here. And the one that I'm going to go into is the geoscience examples. Carolina did work with the depth conversion formula here. I'll go into a geoscience example, and one of those geoscience examples is a net pay formula. So I'll select that item. And just as we look at the formula here, we've got three lines in our formula. One is to generate the gross sand, then the net sand, and then the net pay. When you start looking at the formula here, what you want to do then is hit this blue button down below here just to see the variables parsed out from the individual lines up here. So it parses all those variables out so you can assign them to run the process. In this instance here, for the gross sand calculation, I'm taking the minimum of the lowest known oil uh, structural top, or in this case here, it is the minus 1950 meters TVDSS. So I'm going to use the lowest known oil. It could be your oil water contact for the reservoir that you're calculating. And I'm going to take the minimum of that and the base surface, which is the top ness as it underlies the top tarbert. So I'll take the true vertical depth of the top ness, and I'll subtract this minimum, or this base surface here that's computed. I'll subtract the top surface from that to get the gross isopac, gross sand. And the max, I'll take the maximum of the top surface and the highest known oil too. And the highest known oil here we've got set for minus 1750. Or 1768, sorry, minus 1768. If you want to see all the different elements that you can throw into the arithmetic operations in here, some of the items that you can use in here, both functions, etc. If you go to the help button down here, it'll bring up the arithmetic operations help. And if you want to see all the various functions and everything, there's an option over here, mathematical expressions in here, and it illustrates a lot of the different functions and expressions that you can use within the arithmetic calculator. So you'll see the min-max values that we're using and a description of what they do, plus a bunch of other types of functions in here, as well as describe some of the multi-statement operations that you could do with conditional statements, if then else, or if else operations, as well as some testing statements too as well. So very valuable to go to help and find out what types of tools are available for you there. So in this case, we've computed the gross sand. The gross sand is on the left side of the equal sign here, so it's actually an output. But because it's used again on the right side of the equal sign further down, it's considered a temporary output. So as we look at the variables down here, you'll see gross sand is set as a temp as opposed to a particular value or as opposed to an input or an output value. It's set as a temporary, so it never gets saved. But you can come down here and put a value in here to actually output that temporary grid to keep a record of it if you like. If not, then you could just leave it blank here, and it will just place that information within memory. The lowest known oil is a value that I'm going to put in here for my oil water contact at minus 1950. And these can be, right now it's set as grid. In the formula it's set as a grid, but I can tell it to, I can tell it to be a constant here. So as opposed to a grid or interpolated value, or I want to choose a constant and be able to assign that the minus 1950. And that way, that'll be used within the calculations when we start looking at the building that gross sand thickness. The base formation here, I will assign to the top ness, true vertical depths. And I've had that computed from the previous workflow that I was talking to you about. I'll choose that as our base surface. So it's going to combine the base surface, this top ness depth, subsea depth, with minus 1950 if the 1950 comes above that surface, or the surface dips below the minus 1950. So it always has that continuous surface. The top surface I will choose again too as well. It's going to be a grid. I'll choose my top tarbert net pay grid, which is this one here, depth grid. And it will be combined with the highest known oil and choose a continuous surface here. So if the top surface actually goes above the highest known oil, it'll it'll use the highest known oil value in those areas, and the rest of the top surface in the other areas where it's below the highest known oil. So for the highest known oil, it will be a constant as well. And I'm going to put a value of minus 1768. Okay. Oh, yes. So I've got the values for this first line set in here too as well. Now we're taking sub-C values here, so it's they're negative grids, and I need to be able to take this. The output from this calculation is going to be a negative thickness. So I just want to put brackets around that, and then multiply it by -1 to give me the positive thickness. And then that'll proceed then with the gross sand will be the positive thickness and come down to our net sand calculations down here. So in our, and because I've made some changes to some of the values up in here or added something to the formula here, I just have to hit this button again. And any values that I've set are still set as long as I haven't changed those particular names of the variables that are up here. The next part is the net sand generation. So it's going to take my previously calculated gross sand, temporary data or temporary grid, and we're going to multiply that by 1 minus the V shale. Now, if you had a net to gross grid here or even a V shale grid, you can substitute the V shale for the V shale grid or substitute this whole item in here for a variable and choose your net to gross grid. As an option in here. So when I come down to my net sand, again, it's on the left side of the equation here. So it's an output, but because it's used down here as part of input or on the right side of the computation, it's considered a temp grid as well. So I'll leave that like that, although you could output that too as well for net sand grid. And I'm taking that gross sand grid, which was previously calculated. I'm going to multiply it by one minus the V shale value, or an average V shale value for the interval here. And if I look at the V shale designation here, it's actually left as a grid type here, but I'm just going to throw in a constant value of 0.25. And now I'll look at the final part of the formula that I've got here to actually compute the net pay thickness. I'm going to take my net sand from the previous line calculation and multiply that by an average porosity. My average porosity is a grid as well, and I will choose that grid operation. Tarbert, average porosity. So now I've got all my input elements set. I just need to give a name for my output net pay value here. So I can go this. So I'm going to call it my Tarbert net pay grid. So all my elements are set in here. And I can come over through here because I want to carry through the fault polygons from the Tarbert. I'll take those fault polygons and add it to my my net pay grid, just so I can see where they lie in the net pay, and I can use those if you need to, but we'll be able to see them. And I'll just hit OK. Now that runs through fairly quickly here, and I look at the values that I've got for output here in the vertical range. I don't know if you can see that. I'll make it a little bit bigger. You can see that I've got from 13 to 53 meters roughly for the outputs. So it's positive by generating or multiplying the first gross sand calculation by -1. And it's added a new task here, the computation task. So I can come through here and put this into a group. So I'll create a group again, add it to a group, and I will call this my or call this my thickness calculations or thickness. And I'm also going to rename this particular task here and call it my Tarbert net pay. Now what I do now is too as well, if we're dealing with the next interval and we want to continue to develop this workflow, I can come back up here and add, copy and paste this item up here for the time structure, and then change it to my next formation down, which is the top edif, and create a top edif time structure. Then do the same thing for my depth conversion here. I'll copy and paste the one of these operations in here, and then make that change from the whatever was input for these particular tasks to the top edif to generate the top edif TVD subc grid. And then I could add here now another item in here to do the same calculation I just did for the Tarbert net pay, but do that for the net of pay, or the nest net pay that goes from top nest to the top of the edif, and so on and so forth if you've got multiple series of thicknesses that you want to calculate to be able to take into volumes. And I will keep that as is here and save the operation. I'll do a save as and create a new task file. Call this thickness. So now it has a record of all the different tasks that have been done in the various webinars that we have. So if I come back to my map, pull up my map up here, and I'll turn off my top Tarbert depth map. I'll come in here, add my grid that I just generated. This will be my, go in here and grab my net pay grid. So I have a Tarbert net pay grid. And I will choose my inverted colors here for display purposes and set my contours, intervals. So there's my my net pay, and you'll see that some of the contouring around the faults here, where you've got a real thinning effect, where you've got a thick on one side of the fault and thinning down here. So the contours are following some of that fault structure. I'll take this and I'll bring it down here so I can create a new group too as well. I'm going to go through and add a color bar or two as well for this. And this thing already is set up. I'll put this over here for the net pay. And I will take that down here too as well. And I might do you'll see in this case here, I've got my webinar thickness maps right here already set. And I will take these two items in here and just put them in their own group for the thickness grids. So now I have the three different webinar outputs and everything for time structure, depth maps, as well as the thickness maps. So I can come through also as well, maybe turn on our top Tarbert faults so you can see them overlaying on top too as well. But I can come through and make those different items for display here in one single task or one single list here, and just turn things off and on as I need them. So, okay, let's get back to our presentation and just finish up. Okay, so the prospects to map to volumes webinar series and everything like that. The first two are available on our network right now: the time structure map generation, the depth maps generation. And the one I just did today will be there shortly, within a day or so, and the thickness maps one. And it's available at this link here on our website and looking in the video libraries. The next one in the series is called Computing Volumes from NetPay Grid. And this will be on December 4th and presented by Abelio. If you want to go through and register for this, you can go to our main website under support. There's webinars link there, and you'll see a registration available for you there. Also as well on our portal, portal.petrosys.com.au, if you sign into the portal, you will see a whole bunch of how-to and videos on different workflows and processes that have been generated there, and as a good resource information to refresh memory as well as learn a particular way of doing things. So please check this out. Very good. There's lots of videos and how-to documents that can be downloaded for your personal use as well. Thank you for your time. If you have any questions, I'll type them in there and I will respond to them. Thank you.